In the same way, we can do a hypothesis test for P of a geometric. So here we're going to actually do the whole thing. H0. P is H1. I don't know. Let's read the question. Rare species of frog. They model the number of frogs observed before the first sighting as geometric. All right. The probability of seeing a rare frog they think is P is 0.1. And here we're looking at P not equal to 0.1. And we need to state what P is. P is probability of sighting the rare frog. And I will tell you multiple times here, but this here, context. Right? Context. Right, we'll talk about the types of errors at the end. All right, I just wanted to show you the idea in context there, but I've got a slide at the end that we will talk about. So, X is, and again, a bit of context here. X is number of frogs until see a rare frog. Now this is a geometric. P is 0.1. Now we do need to be careful here. So we want two-tail test. So we need to check both tails. However, right, a good rule of thumb is E of X is 1, is 10. E of X is 10, right? Now, whereas technically, because it's two-tail, we should check, we can either find critical values or we could just take p-values. So we can either check the probability. Sorry, our test statistic is 15. But the expected value is 10. So is there any point in checking the probability that X is less than or equal to 15, right? Is 15 going to be abnormally small, right? Is there any chance of 15 being abnormally small? No, there's no point. There's no point checking that. Whereas technically we do need to, but there's no point checking, right? If we're like I often just represent probabilities with a normal curve, right? Because most of them look roughly like that. We'll get the calculator to show us in a second. But if my mean is 10 and we are looking to see if something falls in the bottom 2.5% or in the top 2.5%, if I got a number of frogs that is above average, there is literally no way it's going to land in the bottom 2.5%. So it's completely pointless. Instead, we are going to look up here and at the top end. Let's go to the distribution mode again. I do like the distribution mode. Is it going to do geometric for me? Yes, it is. Now, in fact, it's not 15. It's not even 15. I'm going to change this to 16. Why am I going to change this to 16? So we do need to change this to 16. Why? Well, phrasing here is poor, actually. Let's assume, let's give the question benefit of the doubt that what it's saying is that the 15th is the rare frog. All right, from our talk about the geometric, let's just assume that with some willful reading in line with the rest of the question, let's not overthink it, actually. 15 is 15. So X is 15, P is 0.1. We get a probability of 0.2287. Oh yeah, like a geometric will look like this, always decreasing. Right, it'll look always decreasing. Yeah, you can't see that on there, can you? All right, it's always decreasing. In fact, what would my critical value be? Let's have a little look. See, 0.025. Where would my critical value be? Apparently 36. Huh. Apparently almost exactly you would need 36 attempts to conclude wrongly. This is much, much bigger than 5%. So there is, let's use our stock phrases. Insufficient evidence to reject H0. What does this suggest? This suggests that there has been no change in the probability. So there has been no change in the prob of seeing rare frog. No, null. So Muda said null hypothesis is H0. That is my status quo. H1 is the alternate hypothesis, which here looks like a minus P. It shouldn't be minus P. Now I'm going to take a second here, at the risk of eating up our time. The way I tell my students is H0 is things as they are now. You'll forgive me this analogy, but it seems to work. It's your current boyfriend, girlfriend, your current partner. Okay? Now, a hypothesis test isn't about... The idea of a hypothesis is absent of any external motivation, you will stay with your current partner. You will stay with your current boyfriend or girlfriend. Why? Because everyone's afraid of being alone, right? And it's not about whether H1 is more appealing. H1 is another person. If you think of that meme of the guy turning around to look at the someone who isn't his girlfriend, right? We are not looking to see if H1 is more appealing than H0. A hypothesis test is basically saying, has your boyfriend or girlfriend done something to annoy you enough to break up with them? All right. It's not about H1 is just your backup. H1 is, I don't know, something to drift over to. It's just what you're going to do otherwise. But it's not about whether or not H1 is particularly appealing. It's about whether or not H0 is wrong. Okay. So one thing I hate seeing is people saying we accept H1. It's never about accepting H1. It's about whether or not you break up with H0. It's whether or not you break up with your current boyfriend, girlfriend. Okay. So yeah, H1 is your rebound. Right? It's not necessarily who you want to be, but you want to be with someone, and H0, your current partner, has done something unforgivable and you've broken up with them. And that's it, right? So you're not going to take a punt on your rebound whilst you're with someone that works. I know this is terrible. This is not how emotional relationships should work, but this is an analogy for statistics, right? You'll stay with H0 so long as everything is hunky-dory. No matter H1, doesn't matter, you're faithful. But if H0 does something bad, like having a p-value of less than 5% or being in your critical zones, then you break up with them and you swap over to your rebound. So your conclusion is always about whether or not you reject H0. Sorry, it should be 2.5%. Someone's still on the stats. So Snuffler, it is 2.5%. You're absolutely right. Absolutely. Anyway, that's the way I try and get people to remember it. Not a healthy way to conduct relationships. Make sure you're with the right person for all the right reasons everywhere. Okay, now we're on to some big boy and big girl maths central limit theorem. So there was, sorry, Rara, one last time. There's no point of checking down here. Well, because we're above average, right? 15 was above the average of 10. If you're above average, you're not going to be abnormally small, right? The two-tailed test, we need to consider the fact that we might have got an abnormally small number. And if you really want to, you can work out this probability. But because 15 is already above the mean of 10, there's literally not a snowball's chance in whatever metaphysical, theological hell we want to use an example, there is no way it's down there in the bottom 2.5%. It's impossible because it's above average.